everyone. Today we're going to be talking about systems of robots. This is what we're going to be going through today. Robots are extremely complex. You've probably seen videos of like the RoboDog or um, even self-automated cars. Those are considered robots. As human knowledge grew, so has the process of developing robots and then becoming more and more complex. As you've seen, we've created robots that are basically human-like, but and use artificial intelligence. Robots require integration of both programming and mechanics. It combines all kinds of engineering fields into creating a robot. We'll go through the history of programming languages, the primary components of robots, and their types of control systems. Coding programs is how robots basically know what to do. Us humans, we have to basically teach the robots and give them direct commands through programming languages. These programming languages are C++, Python, and Java. But recently, as our technology has evolved, robots can now self-teach themselves with AI. Next up is the robot components. First up, we have sensors. They allow robots to gather information in an environment. Position sensors, force sensors, and vision sensors are the main three. Position sensors include encoders and gyroscopes, and they let robots measure where they are in space. Let's say you choose a point in space, and that's the origin. If a robot moves around or gets tossed or turned, the position sensors will let the robot know where exactly it is. And that comes along with force sensors. Force sensors include like scales, compression sensors. They let robots have the sense of human touch. And with that, if you combine it with position sensors, you could run into something which could mess up the position sensor. But the force sensor will let you know like how hard was the impact, and basically lets you know if you actually had an impact. Position sensors don't tell that. And then vision sensors go along with the other sensors and lets the robot see and identify objects around them. They include cameras, barcode readers, or like distance sensors, and they basically let the robot know what's around them. If a robot's driving around and they hit a wall, the force sensor will know that they hit the wall, but the position sensors will know that they bounce back a little, and the vision sensors will help know if it's actually a wall. Next one is actuators. They convert electric energy into mechanical energy. The main three are electric actuators, hydraulic actuators, and pneumatic actuators. Electric actuators are probably the ones you know. They're the most common actuator, and they include motors and servos, and among many other things. And then through motors, they are able to transfer that mechanical energy into other forms of mechanical energy through gears and belts. However, they require power source and generate a lot of heat. Hydraulic actuators are the strongest ones. They use pressurized fluid, usually oil, to create motion. However, they are slow and complex and require a lot of maintenance. Pneumatic actuators use compressed air to create motion. They are simple, lightweight, and cost effective, as they are just air. But they are less precise, and they require some sort of external storage to store that compressed air. Next up is the controllers. They analyze sensor data, make decisions, execute commands to actuators, determine robots' actions and repetitive tasks, and they control a range of repetitive tasks to complex tasks. This is basically like the brain of the robot. You put everything together, the code and the sensors and the actuators, but the controllers lets all the magic happen and tells the robot what exactly to do with its parts. Next up is the types of control systems. An open loop does not use robot sensors inputs, and they are predefined instructions. They are basically used for straightforward, reliable tasks that have no really variables in them. An example is conveyor belts. Their only job is to roll, and so that's easy for an open loop control system. A closed loop control system uses its environment to adjust robots' actions, although it's at set time intervals, so it updates, not constantly, but certain time interval. It's increased accuracy and it's complex. An example of this: autonomous cars. Autonomous cars are strictly programmed to drive, but using its environment, it adjusts how it drives. So it still has those predetermined actions, but the environment is used to adjust them. A reactive control system uses real-time information to adjust robot actions. The picture shows a robot system where basically there's a Microsoft Kinect, and it uses that vision. It's basically a vision sensor and helps let the robot know its environment, and then it doesn't have any pre-planned instructions. So that robot will decide what it needs to do by itself. So unlike a closed loop, reactive has no pre-planned instructions. Like if you take the car example as the last one, the car would not be instructed to drive. The car would see where it is, which is kind of far-fetched, and just say it needs to drive itself at that instantaneous moment. Deliberative control systems uses internal modules and algorithms in the code. Before the robot actually does anything, it collects data and it interprets that data and decision makes before the robot acts. The picture right next to it is a little infographic comparing reactive and deliberative agents. As you see, reactive agents, it's real time. The environment and it goes through all that at once. However, deliberative agents go through an entire process within the processing before actually doing anything in the environment. And that's it for talking about the components of the robot, and I hope you have a nice day.